There, started recording. So on the screens on either side, you should see this, right? You see me standing here. So those of you who your view is obscured a little bit, you should be able to see that way. It does cause a little bit of a problem, though. I didn't think about this. When I want to bring up the PowerPoint, I can switch to that app. But if you're watching this video, you won't be able to see it. So anyway.
Could you split your screen?
Well, yeah, but what I really need is two cameras instead of just one. You see what I mean? I didn't think about that until last night when I was messing with this. So I don't know. I'll keep working on this, but at least I'm getting a recording here. And I can, as long as I don't minimize this, it will keep going. So this is why I say you might want to go ahead and download what do I call it? Presentation 1, Lecture 1. Because then you can have this in front of you on your screen while I'm projecting this screen up here. So I think I'm going to leave it. Video's still going like that. But I'm going to need to go back and forth just for my own brain. But if you're watching the video, this is slide 1 from lecture 1. So there are, I'll start by saying this. All right, just as an example of a numerical value that we might be dealing with this semester, it always looks like this. There's always a numerical value, a unit, and a label. Numerical value, unit, suddenly I don't know how to spell it. And I just say it like that because it's really not until we start solving problems that the label is really going to matter. And kind of the same is true about the unit. What I want to start with is how we deal with just this numerical value. So whenever you do a calculation, you'll have this times this divided by this minus this. All of those values always have these three components. But let's start out by just talking about this, because this is where something shows up that those of you who have taken a chemistry class before, or a science class, you've heard the phrase significant figures, right? Right. So we're going to start there. So I'm not going to talk about the unit or the label, I'm just going to talk about numerical values, just to begin with. And that's where we use the phrase significant digits or significant figures. I always say sig figs just because it's quick to say. But before I talk too much about it, let me bring up how these figures arise in the first place. And they always arise from measurements. So that's what I've got here. Pretend this is just a steel rod, and I'm measuring it with a ruler of some kind. The units don't even matter, but let's say you're looking at some kind of ruler. It says 23 here and 24 here. And what you see is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The interval between 23 and 24 is split up 10 ways. With 10 different units, 10 different graduations is what you would say. So if this is what you had, what you would go is, you've got 23 and there's 24, so you would write down 23 point, 1, 2, 3, 4, 5, 6, so it's between 5 and 6. It is at least as much as 5, not as far as 6, so I'm going to put a 5 here. And this is the key point. If you look between this line and this line, you can kind of tell, you can sort of in your own head look here and go, okay, if there were 10 more divisions and just in here, that's right about the 5 point. It's right in the middle, right? So that means this next digit will be a 5. So there's always that estimation of the last point.
Would you give a little bit of room for roundout there if there's not exact measurement points in between?
Yeah, well, that's exactly what I was gonna say next. You look at that and you think, well, wait a minute, this all seemed very scientific until that last point, because what if it was not clearly at the halfway point? What if it was like that? You still use your judgment, and you look at that, what would you call that? Would you call that 9.9? No, nobody here, 0.9 would be like up here, almost to the next point, right? Would you put an 8 there? You're at least gonna make that less than 5, based on the way that looks right there. You actually do use your judgment. Usually it's gonna be a graduated cylinder for volume that we look at when you're doing this, but if you had a ruler, it's the same way. You're probably not going to put a 5. I would put a 4 or a 3 if it were me, wouldn't you? Do you see what I'm getting at? The 4 and the 3? And you're always going to be probably within at least 1. This is what you were just asking too. You're probably going to be within at least 1 of what it actually would be. And that actually works out. I mean, you would have to really have your brain completely off one day. It would be human error if you wrote 9 or 8 or 7 or 6 right here. You see what I'm saying? So you can always get that last little estimate. That one, I guess I would say 4, maybe 3. You see what I'm saying? And if this did have 10 little increment lines there and you could zoom in, you could probably get this other digit here. You see what I'm saying? So there's always this, here's as close as I can measure, and then I can't measure any more than that. For this, we can't measure any more than that. So there's our 4 digits of precision, I'll say. The more digits we can get, the more precise we're being with our measurement. But there is always a limit, it always ends somewhere. So just to show you how these, what we call significant digits, arise, it's only the ones that I could read, and then this last one, it was a little bit iffy, but we still were able to come down to it pretty close. This would be a complete random toss-up. We have no idea what this next digit would be. You see what I'm saying? All right, so you always read this way. All right, and let me point out that this little process I'm going through here, I'm the writer of this number. I'm the one who made the measurement and wrote this down. I'm going to write it down, and I'm going to hand it off to somebody else, and they have to read that number and be able to tell which of these digits are significant. The way I've got this written, it's not obvious why this matters. I mean, if you were reading this number, so now you're the reader of the number, you're not the person having to make the judgment, somebody else has already done it, and you're assuming they've done it correctly. And you're reading this number, you would say, how many significant figures? It's also another way of saying how precise the number is. But I'll say significant figures or significant digits from now on. If you walked up and read this and you were like, oh, yesterday somebody made this measurement, now I have to do something with it. You would look at this and you would go 1, 2, 3, 4. That's 4 significant figures. Those of you who have seen this before, that makes sense, right? 4 significant figures. Those of you who haven't, all you have to do is look at the numbers here, count them up, and go, okay, that's for, I say SF, just for brevity. I also sometimes say sig figs. But that is 4 significant figures. And that's not confusing. There's nothing about that that's confusing. If I said, that, or I said, what I'm doing here is avoiding zeros, just for the first introduction here. So these 4 made up numbers, this one is the one I was pretending I got from here. That's 4 significant figures. This is 1, 2, 3, 4, 5, 6, 7 significant figures. That's 7. 1, 2, 3, 4. That's 4, and that's 4. What am I making them all 4? That one's 3 significant figures. When those of you who studied this before, did significant figures, were they obvious to you? You all understood them completely? No confusion whatsoever? Some of y'all aren't being honest. Most people hate this. You shook your head. You didn't like significant figures?
I just did not have a very strong
Okay,
class.
good. That's what I just want you to go, yeah, I hated this. Part of it I didn't understand. Well, here's how simple it is. There's 4 there. There's 4, 5, 6 there, 4 there, 4 there, 3 there. That's all you do. You just count the numbers. The only reason this is so easy because there are no zeros. The zeros are what caused the confusion. And notice I haven't put a 0 anywhere. Okay. So I'm going to bring this back up. If you missed class and you're watching the video, you can't see this. But the first rule is all non-zero digits are significant. And that's what I did. I came up with numbers that have no zeros anywhere that could possibly confuse you, and you just count them up. So that first one on the list there is the obvious easy. If there's no zeros, it's just everything you see there. You count them up, and that's how many significant figures there are. That's the precision of the number. They do interior zeros next. I'm going to do leading zeros and trailing zeros. So that's 3 and 4 on slide 1. Let me talk about leading zeros and trailing zeros. And now I go back to being the person who is making the measurement. Let me, so this was, what did we say, 23, 1, 2, 3, 4, 5. So 23.5, that's the 0.5. And this is, I said I would probably judge this to be about a 4. Okay. So that's this steel rod. But what if this steel rod was really there, and when you looked over, it really looked like it was right on this line? All right. 23, okay, 23.5, yeah. And you still got this distance that you can look at. But what if you read this and it would happen to be right on the line here? If it was just a little higher, we would put a 1 here or a 2. If it was a little higher, we put a 3 or a 4. But since it's right on that line, we actually put a 0. And that, I only put that 0 there because I was actually able to measure it. So this is trailing zeros. This is rule number 2, I think, over here. Yeah, rule 2. No, rule 3. No, it's rule 4. What I just put there is a trailing 0. It's 0 on the far right. And the reason it counts is as the writer of this number, the reason I'm counting it is because I actually measured it. I actually broke this down into 10 increments in my head, and I'm like, well, wait a minute, it's right here at the very beginning. That's how this trailing 0 arises, because it was actually measured. You see that? All right. Now, forget being the person who reads the number. You're the person who comes up the next day and reads the number that someone else wrote. If this person actually measured this last one, and it happened to be a 0, then they write it. So when you come up and read this trailing 0, it counts. Well, let me say this. You could write this number, 23.50. You could write it with as many zeros on the left that you want. You probably wouldn't. But this is what we call the leading zeros. And that's number 3 on that list. Leading zeros. It's probably obvious to you, so let this be obvious to you, that these don't count towards the significant figures. These have nothing to do with the precision of this number. They're just there, they're like placeholders. They're just, and no one generally even writes numbers like this. All of these don't count towards the significant figures. And we usually don't even write those. The leading zeros, we usually don't even write them. They show up like on a, if you pump gas, some old gas pumps have those things that flip over, so there has to be a place for the digit. But it will just say 0 until you get up to that digit until it turns over. So that's about one place you can think of. There are some old alarm clocks that used to do this. These days, everything's digital, so you probably don't even see them. But these don't count towards the significant figures. These here, these are the trailing zeros. And they're only ambiguous in the fact that I've chosen to write this with as many as I wanted to write. I could write an infinite number of zeros here. Does that make sense? I could write an infinite number of zeros here. But the person who made this measurement, who read this, only put one digit here. So that means this counts towards the significant figures, but nothing to the right. Therefore, when they wrote the number, they didn't include any of these because they didn't measure. They couldn't measure. So if you see a number, all the leading zeros, and I should say, let me come up with a completely different. That number, these are leading zeros, and it doesn't matter if you trip over the decimal point as you go. These are leading zeros as well. None of those count towards a significant figure. You start on the left, and if it's a 0, you don't count it. You go to the next one. If it's a 0, you don't count it. You keep doing that, even if you stumble over the decimal point. If you just keep seeing zeros, those don't count towards the measurement. That makes sense? So these are leading zeros. These are also leading zeros. If you have a number that's fractiony like this, these zeros don't count either. These were the measured thing. None of this was measured. So this is 3 significant figures here. 3 significant figures there. Because none of this counted. So the leading zeros, those are kind of obvious. They don't count. The trailing zeros, if you're the reader of that number, and there are zeros on the far right, they count. Because the writer of that number wrote them. So you're assuming the person did it correctly. That just means it was right on the line when they measured it, so they put that 0 there. And if you could zoom in and found out that the next 10 increments that you could look at in the next level, if that happened to be on the line, then the writer of that number would put another 0 there. And go, okay, well, the last 2 zoom in, we were right on the line, so it was 0, and it zoomed in again, and it was right on the line, so it put a 0. The writer of that number puts it there because they measured it, not because there's theoretically an infinite number of zeros to the right. There's theoretically an infinite number of zeros to the left, and theoretically an infinite number of zeros to the right. The ones on the left never count. The ones on the right, if the writer of that number put it there, then it counts. So zeros on the right count, zeros on the left don't. That is 3 and 4 on these rules. By the way, these slides, I pulled them right out of our book. I just copied them out of our book. So this is in that key chapter, essentials chapter. So leading zeros, trailing zeros. Leading zeros never count. Even if you stumble across a decimal point, those don't count. Trailing zeros always count. The writer of the number put it there. That means they measured it. They wouldn't have put it there otherwise. And then all non-zero digits are significant. That's where I started. And Okay, number 2 here, interior zeros. There's another place that zeros can show up. What if I had 2,301.60310? Okay, I didn't bother to write any zeros out here, but usually you don't when you're up above the decimal point. So I didn't write any leading zeros. These are what I call sandwich zeros. The book calls them interior zeros. But all of the significant digits are always contiguous. They're always together. So if that's a significant figure, and it is because it's non-zero, and that's significant, and it is because it's non-zero, the one in between, that's significant as well. That was actually a measured one. And maybe that's obvious as well, but as long as that's an interior zero, that's an interior zero. So those count too. But they really count because significant figures are contiguous. 1, 2, 3, 4, 5, 6, 7, 8. And then you have a trailing zero, and the writer of this number measured this, so they wrote it down, so that counts as well. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 significant figures. So it's the zeros that make these confusing. If you're looking at a number and there's no zeros at all, you just count up the numbers you see. It's that easy. It's the zeros that cause the confusion. Leading zeros never count, even if you go across the decimal point. If you see something like this, none of these count, including these. That's 3 significant figures. Make sense? Okay, so we're dealing with the numerical value of one of these numbers I'm talking about. Oh, there's one more. Chemistry is a science where here are the rules you follow. Here's like 3 rules, and you follow them 100% of the time, except there's always one little weird category where this is always true, except. This is the weird rule for this. If I measured, okay, so if you've got a number like this, 2,300, and I'm not going to put the decimal there, I'm just going to write 2,300. All right, the convention here is, if these zeros are significant, you put a decimal there. You actually write it that way. You probably have never seen that in any math class. That might look weird to you. But if the person who measured this measured these digits and measured these 2 digits, and it's just above the decimal, they put the decimal there to indicate that that's 4 significant figures. If they wrote without the decimal, that's 2 significant figures. What they're saying there is these aren't significant, these just sort of locate where the decimal would be. It sort of indicates the magnitude here. So that's a weird little rule, but we stick to that. This book acts like this book says something like some textbooks put a decimal point after 1 or more, whatever they're saying, trying to explain there, they don't explain it well. Is this convention. If these are not significant, if these are significant, you put a decimal there. If these are not significant zeros, you do not put a decimal there. So the last non-zero digit and then some zeros up to the decimal, whether you put the decimal there or not, indicates whether or not that's a significant figure. So that's a weird little rule, but it's there, so be aware of it. So that's the numerical value without adding units and labels. There are some other rules we can deal with. But the next question is, how do you deal with these in calculations? So on slide 2 here, it tells you there's the multiplication rule, or the multiplication division rule, that's number 1. And addition subtraction rule is number 2. So let me go into those. This is the multiplication division rule. You can, before you even bother to calculate anything, decide something important. How many significant figures are here? 3, 2. Give you credit for guessing. It is 4. There's no leading zeros. There is one trailing zero, and the writer of this number put it there. So that's 4. This is 4 significant figures. How many significant figures here? There's no zero, so it's easy. 3, yes. What that means is the lowest number of significant figures you have in your input values, that's the significant figures you need to have in your answer. This is the multiplication division rule. And what you do is, I suppose you guys are going to have to use these calculators for tests. Scrawled across the desks. So you might as well get familiar with them. I'm just going to use my calculator app to do this. But I'm going to put 23.10 times 14.1 equals this is what my calculator says. 325.71. I just wrote down everything my calculator did. And I think it's worth going through this steps, especially if you find this confusing. Just write down everything your calculator gives you on this side. And now I'm going to round it to 3 significant figures, which means it's those 3 places that I'm going to keep. I underlined the first 3 significant figures of that number. You with me? You do have to decide whether you're going to round it. So I underlined 3 here because the lowest number of these was 3. So underline 3. I am going to look one more digit out from there to decide whether I round. And so if it's 5 or more, you round. If it's 4 or less, you don't round. I'm sure y'all have heard of that. The 7 rounds the 5 up, so that's the answer. 3 significant digits. You with me? I have some examples. Should I do the examples now? Okay, number 3 here is just telling you how to round, but I bet all of y'all do that. If the 7 is, if this digit is 5 or more, you round up. If it's less.
On an equation where there's no decimal after 1 or 2 zeros where it's ambiguous, do you follow the same rule?
Yeah. If you had, let me make a different example that has one of those. If you had the ambiguous, it says ambiguous, but it shouldn't be ambiguous if you follow the rules. If someone wrote this down, the writer of this number, if someone wrote that number down and you come in the next day and they're going to use it, 2300, if they did it correctly, if they wrote this, then that's 2 significant figures. If they wrote it like this, then that's 4 significant figures. If one of these zeros is significant and the other one is not, you have to use scientific notation, but I haven't gotten to that yet. But here's 2 different ways to write this. And if this was times 2 significant figures, the 14.6 is 3 significant figures. If they wrote this down, then you need to have 2 significant figures here. And if they wrote this down, then you need to have 3 significant figures here. So I did this, I made you pretend you were the writer of that number, just to show how these trailing zeros might show up, and also kind of what precision means, how many digits you have. But after that, I'm saying, pretend you're just the reader of the number, and you're trusting the person who wrote the number to follow the conventions correctly. So if you had this problem to solve, you need this to be 2 significant figures. If you had this problem to solve, then you need this to be 3 significant figures. So in my calculator, I'm going to go 2300 times 14.6 33,580. Either way, that's what my calculator is going to say after I calculate it. But if I need this to be 2 significant figures, what I'm going to do is, I like underlining, so let me get that out of the way. I need those 2 to be the significant ones. And here, I need these 3 to be the significant ones. This 5 rounds up this 3, so my final answer is 3, 4, and the rest of these just become zeros. And if I want it to be 2 significant figures, I'm not going to put a decimal here. This one that's 3 is going to be 33400. These just work out. So without all of this, if you walked up to this number and I said, how many significant figures are there? You should see it as 2 because there's no decimal here. And this one you should see as 3 because there's no decimal here. So yes, that weird rule, whether you put the decimal or not, the book calls these ambiguous, but they're only ambiguous if you do it wrong. Saying that it's ambiguous, I think it's the wrong way to put it. Does that answer your question?
Yes, sir.
What's the next rule? The rounding rule. Okay. So on this first slide, slide number 1, the complicated part was if there are zeros. It's always the zeros that make you double think whether something is significant or not. On this page, it's the 4th one, the multi-step. I didn't do addition and subtraction yet, so I'm going to do that next. So number 1 was multiplication division. That's what we just did. And then we summarize real quick by saying, when you're doing multiplication or division, divided by, so this number times this number divided by this number. When you're doing multiplication division, you look at the significant figures of your input values, and the lowest number, that's the significant figures that have to be in your answer. So you round back to them. I'll do this one real quick. How many significant figures? I'll put no zeros anywhere, so this should be easy. 3,
5, 4.
All right. So what does my answer need to be? 3, yeah, because that's the lowest number of significant figures. I happen to put no zeros there, so it was obvious. 23.6 times 14.14 divided by 16.1. All right, my calculator says and if you have trouble with this, I'll say it again. You should just go ahead and do this step. Write down everything your calculator says. My calculator says obviously, I'm not using all of those, but it helps to write them down. This was 3 significant figures, this was 5, and this was 4. The lowest number was a 3, so underline the first 3. And then we're going to look one more beyond there, the 7, to decide what to do with the 6. The 7 rounds the 6 up. That's the answer. All right, contrast this with the addition subtraction rule. Is all of that on the here? I'm gonna write that here. All right, addition subtraction rule. Addition subtraction rule, we've talked all this time so far in class about how many significant digits. Try to remember that the addition subtraction rule is not about that. It's not about how many significant digits. It's how many digits after the decimal. What I'll underline here is that's 1, that's 2, and that's 4. The number of digits after the decimal. That's what we use for the addition subtraction rule. The lowest number is the one you use. So my answer, it doesn't matter what's above the decimal. Below the decimal, I'm going to round it back to the first digit after the decimal, like this. Again, going to use a calculator. 31.9 plus 15.11. No, that's minus 31.9 minus 15.11 plus 116.1463. And my calculator says, this is everything my calculator gives me. 363. That's what my calculator says. Now I'm going to underline all the digits I want to keep. I'm going to keep 1, 3, 2, and 9. That's the first digit after the decimal. So now I know that I'm going to have 4 significant digits as my answer. But what I'm really paying attention to is how many after the decimal. So underline the 9. Now I will look at this 3 and go, do I round the 9? But I don't need to round the 9 because it's a 3. So my final answer is, that's my final answer, 132.9. So that's the addition subtraction rule, and this is the multiplication division rule.
If you did have to round the 9, what would the answer be? Like if it was the 6 behind the 9 instead of the 3?
If I calculated all this out, oh, I see what you mean. That's a point of confusion too, I know, but let's say I had, if I had this and I was keeping these, yes, the 9 rounds up, but just think of it as the 9 is going to become a 0 and this is going to become a 3. That would round up to 1, 3. That's 1, 3, 3.0. That one would round to this. If the next digit here is a 9, it becomes a 0, and then this digit increments 1 up from there. If your brain can like do this, this is how my brain does it. I look at this as 29, and it's going to become 30. That's kind of a weird mnemonic way of thinking of it, but that will show up sometimes in calculations. So multiplication division rule, you look at how many significant digits. Addition subtraction rule, you look at which one has the least number after the decimal. Sometimes it's even 0. There's none after the decimal. So that's 1 and 2 on slide 2. Number 3 just tells you how to round, which you probably already knew. Number 4, I already said this, but number 4 is the one that gets tricky. It's not super tricky, but what you do when you have multi-step calculations. If you have a calculation that's times this, divided by this, divided by this, times this, divided by this, you just stick with the multiplication division. If it's plus this, minus this, plus this, you just stick with the addition subtraction. But if they're mixed in, if you have something like now you have addition subtraction going on in here and multiplication division going on in here. The way you handle this is, of course, you're going to do what's in the parentheses first. So 14.16 minus 2.1. My calculator says that's what my calculator says. It didn't even give me any more digits to here. All right. 2 after the decimal, 1 after the decimal. So I'm going to put an underline right here just to remind myself that that's really where I need to round this back to. You see that? But I'm going to keep this 6 and use it in the calculation. So that's the twist with multi-step calculation. Is you're still going to use whatever bits change, whatever little bit here that you have. You keep that for your calculation, and then get to the final calculation. I've got 12.06 in my calculator, and now I'm going to go times 2, 3, 4, 1, 4. Does that make sense? This is 4 significant figures, what I've got here, but this little underline was telling me that this really should be 3 significant figures. I'm just keeping that to keep the accuracy of my calculation going. So I'm going to think of that as 3 significant figures rather than 4 when it comes to my answer. This is 1, 2, 3, 4, 5. 5 significant figures there. So when I do this calculation, I've got 5 significant figures there. This one's supposed to be 3, but I'm keeping this 6 just for my calculation. So my answer needs to be 3 significant figures. That's the twist. Rule number 4 is you keep track of your what digit is your least significant. So 12.06 times 2, 3, 4, 1, 4. My calculator says that's what my calculator says. But this here tells me 3 significant figures is what I'm keeping, so it's those. I need my answer to be 3 significant figures. The 3 does not round the 2 up, so I've got 2, 8, 2, and I'm going to put a 0 there where the 3 was. And I'm not going to put a decimal there, so that I indicate that there's 3 significant figures. Did you follow that? What I have next is exercises that you can do. So we've done slide 1 and slide 2. Let me go to exercise. Towards the end, at the end of this presentation that I've put together, these 2 pages at the end of this presentation have answers to problems that are in the book. Your book gives you the odd numbers. So on the left side of slide 7, I've just copied this out of the book in the appendix, so you don't have to go digging around looking for them. And on the right side is the even number questions that they don't give you answers to. I'm giving you the answers to all of them. And this is what you can do to practice. We'll do some of these though. So let's go some of these. We're going to, oh, I have to go to Pearson. Hopefully it's in my favorites. Lab mastering, okay. Anybody have trouble getting the book? Well, hopefully you all have the book and you're able to go to Pearson text. Go to Pearson. Any trouble with the book? Yeah, had problems with it?
Whenever I go to read it or click on e-text, it says I need to log in or just download Pearson Plus. And it says it's for all my devices. And when I go to the it says it's on top of it, but it's not. I mean, I can't download it. It needs to download it. And it's all the options, which is new because I use
my best thought is to contact Pearson. Say, I can't get it. Did you go through the instructions that I had on D2O? Yeah. Contact somebody. I do have some that's not on Pearson, some practice problems, but work on that between now and Friday.
The part of the addition and subtraction, we did a number after the decimal. How come your final answer? Is that just because?
How come I'm one?
How come your final answer didn't need any point after the decimal? Is that just because?
It's only for this part that we had to find the one after the decimal. The rest we did with the addition, the multiplication, division. This one should have been 3 significant figures. After we calculated this out, it wasn't necessarily going to be 3. The whole point was, this has 1 after the decimal. This has 2 after the decimal. So this one needed to keep 1 after the decimal. If we did that, if we made this 12.1, then this will be 3 significant figures. We kept it this way though, to preserve accuracy.
So just to understand how many significant.
You guys can't hear her ask. Everybody? I know y'all are talking about this. I can't hear her.
So that the purpose of that was to figure out how many significant figures your final answer needed to be.
This was to figure how many significant figures was going to be in this number that we multiplied here.
Okay.
We looked here, we went, that's 1 and that's 2, so this needs to be 1. If this was 1 after the decimal, that would make this 3 significant figures.
Okay.
But we kept this extra bit here. We didn't turn it into 12.1. We kept it as 12.06 so that once we multiplied, we would preserve a little bit of accuracy here.
Okay. That makes sense.
Let me say this about, I'm trying to bring up. What was I going to say? I forgot what I was going to say. So those multi-step, we'll do some more of those. We're going to practice this a bit. So we'll do some more of those multi-steps. What was I going to say? I was going to say something kind of cool and deep, but I forgot. All right, so when you go to Pearson and you open it up and you've got this table of contents thing, then you can see the chapter we're in is chapter E. It's really chapter 1. And I started at E3, but if you scroll down a bit, there are these 3 sections at the end of the chapter This is where you'll find extra problems to solve. So that's where I'm going. It's the self-assessment quiz and the exercises part. This says self-assessment quiz and then the name of the chapter. The next one says chapter summary and then the name of the chapter. And then it says exercise essentials, name of the chapter. There's some self-assessment here. There's not many. I'll give you a list of these to look at. But so this is where you'll get your practice for these. So if I had
No, our first question was about converting.
okay, I'll get to that. That's kind of where we're going. This is so oh, they're here. They're here. All right, well, let me skip that part. Go down to where it says exercises. This is for you later to practice. You'll want to go down here where it says exercises. And the ones you want to go to based on what I've covered are these. So slide number 7 and slide number 8. These are straight from the appendix 3, the answers to some questions. So what I've got here is 39, and over here on the right I've got 40, 41, 42. This is slide 7 of my presentation. 39, 40, 41, 42, 45, 46. The next page has 47, 48, 49, 50, 51, 52. And these are all the answers. But let's go over some of these. The first one, 39, so I'll go down to 39. So if you're watching the video, you can't see this, but it's the last section in E, number 39. So number 39, let's skip this. They give you the answers to these, so let me do the ones that don't get answered. 40. So practice 39, if you look here, you've got 39 there. So those answers are way in the appendix in the back, but I got those for you on here so you don't have to go digging around looking for it. 39, so 40. 40 is the one that we do. 40. This problem includes units, and I haven't talked about units yet. But that one's in miles, that's A. B is 0.00140. M is meters, but we'll get to those. So this problem is asking you to identify which of these zeros count towards significant figures and which ones do not. You can ignore the units. That's miles, meters, kilometers, meters, but you can ignore those in this problem. Just look at the numerical value. All right. How many significant figures are in this number? It is 6. There's no leading zeros, and if there were leading zeros, you would just ignore them. There's no trailing zeros. There's not even a decimal here. And these two zeros are sandwiched in between non-zeros. That just tells you that everything that you're looking at there counts towards significant figures. So this is 6, How many significant figures here?
4.
It is 4. These zeros are leading zeros. You get your first non-zero digit, and you count up to here. The writer of this number put a 0 here, so it counts. So it's these 4 count. This one, all of them count. This one is 4 significant figures. How many here? This is also 4. These don't count, those are leading zeros. The 5, the 7, and the 1 count, and the 0 counts because the writer of this number put it there. There's technically an infinite number of zeros out this way. But this 1 0, the writer of this number actually measures, so they put it in, so that one's 4. What about this one?
5.
This one's 5. These 2 zeros are sandwiched, and there's no leading zeros, there's no trailing zeros, so all of those can go. So expect a question or two on the test like this. That was 40, so I've indicated those here. Let's get to what else do we have? I'll go for 42. Again, ignore the units. I'll talk a little bit about units before we stop. That's seconds. Oh yeah, I have to cover scientific notation. 4, 5, 6, 7. So this is 42. These answers are in the PowerPoint presentation. How many significant figures are in A? How many? 4? You said 1.
It's 3. Wait, no, sorry.
This one, it's 1. It's always the zeros that are confusing. These are all leading zeros. Then there's a 1, and there's nothing after that. That's it. It's just 1 significant figure. How many here?
3.
It's 3. The leading zeros don't count. If there's trailing zeros, they do count if it's below the decimal. So that was 3. I forgot what those units were, but we're ignoring units right now. Let me skip this one right now. I wrote this one, D, 4100 without a decimal. It's 2. This one's 2 significant figures. If I put a decimal there, how many would it be?
4.
Then it would be 4. This one? 4. That one's 4. No leading zeros, no trailing zeros. These are sandwiched zeros or interior zeros. So there's a few more of these that you can practice. So we'll go to 9:45, 9:50, is that right? So let me go back to the PowerPoint. Good, that's still going. Sometimes these videos just shut off, so I'll keep checking it. So I will continue. So we basically just went through slide 1 and slide 2. I haven't even talked about scientific notation. But the rest of these I'm gonna introduce, I guess, Friday. But for now, look at slide 7 and slide 8 on there and practice these from the back of the book. Oh, you know what? I will do some of these calculations. We still have to do that ACS test, and technically you're supposed to get 2 hours to take that test. But I'm telling you, I don't care if you just make Christmas tree shapes in your thing. So I'd rather do a little lecture than that pointless test. It's a department policy, and we all know it's crazy. I don't know why we keep doing it. Let's see, 47. Okay. And that's an odd one, so I'll do 48. So let me do a couple of these. And then y'all can do this next. 48. Here's some calculation. Number 48 has all right, here's how I'm doing A. I'm going to go 9, 7, point. Okay, which rule am I using here? Multiplication division rule. When you're using any of these rules, you can start by looking at your input value. How many significant figures are here? This one's 5. No leading zeros. You have one trailing zero. 1, 2, 3, 4, 5. That's 5 significant figures. How many significant figures here? 4. It's 4. 1, 2, 3, 4. How many here? 5. So what does our answer need to be? 4. It's got to be the lowest number. So my answer needs to be 4 significant figures. So you can do that right at the beginning. And then the next step is just to use your calculator. 97.530 times 4.020 divided by 100.04. So here's what my calculator says. That's what my calculator says. But I need to round it back to 4. So I'm going to underline those 4 digits. And now what do I do next? See if it rounds. I look at that next digit over, the 1. That does not round to 9. That's the answer. Multiplication division. Hopefully that's what I have in my PowerPoint. 3.919. 3.919. So I did put that here. And let me go to the next. So these are all multiplication division rules. The next one, addition subtraction rule, is down here at number 50. And that's next here. B is 1, 2, 3. now we're using addition subtraction rule. And you can start by identifying something about your input values. What you're identifying now though, that's 1 after the decimal, that's 2 after the decimal, that's 2 after the decimal. So how many after the decimal do I need? 1. So I need 1 after the decimal. Identify that, and then I can just put the rest in the calculator. 1, 2, 3, 9.3 plus 9.73 plus 3.42. My calculator says I need to keep 1 after the decimal. So that's going to be my last digit place. So it's those that I'm keeping. I look at the 5, it does round to 4, so 1, 2, 5, 2, 5. That's the answer. 50B. 1252.5. So what I'm saying, as far as test 1, to practice for test 1, do these problems on slide 7 and slide 8 by going to the end of the chapter. You with me? Okay. So you can clear your desks for this BS little exercise for us to do. Who does not have a number 2 pencil? If you have a mechanical pencil and you can't tell, it's probably fine. Hey, you guys, I only use that Pearson site for the textbook. All the other functions on there I don't use, and apparently it's popping up with assignments for you. Don't worry about that. You don't have any assignments that are due. I gave you what you're supposed to do. It's those practice problems in the PowerPoint. Nothing else is due. You're just practicing what we did today, and that's it. That's all you need to know for the test.
It's just the ones in the PowerPoint, like not the
Yes. Yes. Any other assignments that are popping up on that Pearson site, ignore them. I just haven't figured out on the site. Okay, clear your desk.